Hello, everyone. My name is Dan Baxter. I'm a sales engineer with OpenGear. A little bit about me. I've been in the out-of-band management field for about 15, 16 years. In the last 4 years, I've seen a big change where cellular technologies have started to be embedded in out-of-band and routing technologies as well. So I wanted to come and talk to you today to give you an introduction into cellular routing and cellular out-of-band management, because what we're finding is, although many of our customers can make the internet work and keep their organization's networks going, when we start to talk about things cellular, it becomes very educational. So just wanted to give you a really broad overview today, because cellular adoption, obviously, it's no mystery. There's huge adoption going on today. In America, there are more cell phones than there are people. And I think that's true around the world, 4 billion people and 3.7 billion cell phones in the world. But what's really surprising is that in the last few years, the trend's shifting for people using their cell phone, using cell technology to access the internet. And so what this is doing is driving your options and your choices for using cell technology. So as network admins, network architects, it's really important to understand your options, your carrier options, your plan options, what the technology is, so that you can make the right decisions about implementing the technology and following best practices around that. Today I'll be talking about two of the applications in cellular arena. Cellular routing, which is using the cellular interface for routing traffic between sites, and cellular out-of-band, which would be using cellular to get access to a remote site. If there was a network outage, you'd get access to your remote out-of-band management equipment, bring the network up and running. They're two different but similar scenarios. So both share the idea of a primary and a failover interface. Both are similar in the security concerns, and both share similar IP plans that you can get from the carrier. But there's differences in how you deploy them, what kind of security policies you'd put in place, and also the costing on the plans. So in the cellular routing form factor, you get kind of two categories. You get adding cell to existing routing infrastructure, such as a module that might go in a router or an external USB modem. And then you get cellular routers that are actually, the cell is embedded right inside the router. You can get two kind of categories in that. The consumer-grade products and the industrial-grade products. When we talk about cellular routing within, how people using routing technologies within these, this category, you'll find there's HA, it's high availability. The other one's called IP pass-through sometimes in the industry, or a third situation where the unit is standalone and it is the only routing for the location. In HA, there's a protocol handling the failover, and typically there's two physical devices. One's a primary, one's a backup. If the primary is the main router at the site, it's going out the WAN link, and if there's a failure with that, then the second cellular enabled device will kick in, and the end hosts don't know the difference. VRRP is a very commonly used routing technology in these scenarios. Then there's another mode, IP pass-through. This is typically where you'll have an existing router at a location, and you're looking to introduce a separate failover link for that router. So that main router will handle all the failover. It'll handle all of the changeover to that link. In that case, you're protecting yourself from either router failure or a WAN link failure, because there's really different modes depending upon what you're trying to achieve. So the IP pass-through, it really depends on the primary router being available. If that primary router fails and the hosts were using it for their failover, obviously they're not going to know about the change and know how to get over to that cellular router. Cellular out-of-band management form factors are very similar to the routing. There's items where you'll take an existing install and you'll add cellular to it with a USB dongle or an external adapter, or you can get a device that has the cellular built directly into it. It's embedded inside the device. So external modems are great for adding, cell to an existing installation. There is a drawback, though. It introduces a failure point. Dongles and the cables are vulnerable. They can be damaged or moved. And you also have third-party driver considerations. Is all of the device you're going to bring in and match up to the existing equipment? is that driver going to be supported? Embedded, on the other hand, it gives you an advantage of removing that single point of failure. And because this technology is built around current cellular technology, there's going to be a nice fit. So there's a nice fit at a hardware level, and there's a nice fit at the feature set. You can recognize a purpose-built embedded cellular out-of-band management device primarily around the form factors. It'll be higher port densities. It might be RJ45. And there's also a related feature set in the firmware for failover of the handling the failover and also the notification. Products that are kind of, I call them as an add-on idea. They typically be a smaller form factor, smaller port density. They'll have a DB9 on them, usually a lower port cost, and they're typically not meant for a data center, maybe a remote site location. Crucial to any of this is the idea of failover. So the primary link's up and running, you'll use that link with the device, but then there'll be some type of trigger, whether a ping trigger or an interface state change, and the device will recognize that change. And at that point, it'll bring up the cell interface. In some cases, the cell interface will be dormant, meaning it has a different route gateway on metric on it, or it just might be entirely turned off until it's needed. So the challenges around that in terms of the out-of-band cellular strategies is that it's really vendor focus related. What is the vendor's focus? Are they embedding directly into the device? Is it an add-on? And that kind of interplays with your need of am I looking for an add-on to an existing install, or do I want to have something that's directly embedded into the device? So you got to kind of ask those questions going into it. You know, I recommend avoiding dongles because it's a point of failure. Just, you know, as a veteran in the out-of-band world, I know what happens to modems, and external cell modems have the same vulnerabilities. Now we can talk a little bit about some of the cellular considerations. One of the things that's necessary is to understand what your options are, the costing, the types of plans you can get from your carriers, as well as the wavelengths, because it comes down to the bandwidths and the wavelengths. There is no one size fits all. And in America, it's very, very carrier specific. So internationally, it's a little different. It's more about the wavelengths than the carriers. The modems that we're getting from the devices are matched to the wavelengths of the carriers. For instance, in America, LTE, both Verizon and AT&T are going to use a 750 megahertz range, but they're going to use different bands. AT&T uses band 17, and Verizon uses band 13. And the carriers in America will certify the devices to be used on their network. You cannot take an AT&T product and put it onto the AT&T network, meaning you can't take that SIM and move it between the vendors or the carriers. They hand out an IME number. It's much like a MAC address, serial number. It's an identifier that registers that number, that device to your account, but it also certifies it to work on the network. Because of that, you'll order your equipment for AT&T, or you'll order it for Verizon in America. And again, in different countries around the world, it's a little bit different. 3G, 4G considerations, comparing them, to me, it really falls down into coverage and speed. I'm finding a lot of not only the geographic coverage for 4G is better than 3G, I'm also finding the strength signaling being a lot better for 4G, but of course it's really going to depend on where you are and the geography of the towers and services around you. But the speed's also better. The carriers are saying 50 megabits download, 100 megabits upload, theoretically, I guess. And compare that to 3G, it's 1.8 and 3.1. So if you're doing out-of-band management, in your SSH primarily, your speed difference may be different than somebody who needs to route that traffic across that link when there's an outage. There's a nice table on Wikipedia for both America and international, because it becomes a matching game of saying, which country am I going to, what carrier is it, and what megahertz do they support, what bandwidth, and then you have to go to the hardware, and you have to match up a similar hardware on the cable, on the cell modem, and also on the firmware. And it really gets complicated internationally. Sometimes different regions in Canada will have different bands supported. So you really need to, these are great references up on the Wikipedia. There's two types of accounts that typically I see customers going with. There's a consumer grade account, then there's business grade accounts. And the difference really is that consumer grade account is the iPad, a tablet. You might walk into the Verizon store and sign up and get an account through Verizon. A business, you're going to be a business account. Maybe everybody gets their smartphones in the company from one carrier, and maybe you've got a mobility person in sight. There's typically a sales rep and an SE assigned to each customer, and AT&T and Verizon I know are both this way. You get quantity discounts on the business side, so that's important to know. When we talk about the plans, they fall into those two categories of the routing and the out of band. For the routing, it's a LTE network routing plan. 30 gigabyte is about the smallest data rate you can commit to. In the out of band arena, it's different. It's a machine to machine plan. They categorize it differently because it's used differently. And 1 meg is where you can start off. So there's a big difference there between those two types of plans. Regardless of the types, there's 3 types of IP addresses you can get. You can get a private NAT address. That's usually like your iPad, your phone, it falls into that category. Or there's a public address where it's a static IP or a DHCP, sits out on the internet. That's handy for some people. And then there's a private carrier network cloud. Not a lot of people know this option, but the carriers can create a private network cloud for you. In the private IP plan, the pros and cons are it's easy to get going. There's a low upfront cost. The downside is it's a private NAT address. So you have to have some kind of way to get to that device, and that usually has the devices usually initiating that as an outbound SSH session. It could be an outbound VPN session back to a VPN gateway, and that way you can get over the limitation on that private NAT plan. Public IP plan is great if you need to have a device sit out on the internet. It's going to be either static IP or it's going to be DHCP. If you do DHCP, you can use DNS services to let you know if the IP address has changed. You may want to think about VPN technologies and we'll talk a little bit about security in a little bit here, but you can leverage VPN technology on that device since it sits directly on the internet. It's easy to access, but it's got to be secured. There is a one-time setup for this type of account. It's $500. So if you call up the carrier and say, I want a private network, or I want a public IP, it's going to be $500 one time. And then as you add devices in, you just pay a monthly recurring fee on those devices. So the pros and cons of the plan is the pro is it's on the internet. The con is it's on the internet. So it all comes down to security. You want to firewall the interface. You want to control the services that are active on the interface. And you want to control the amount of time that interface is active. If it's not going to be used all the time, there's some sense in making it not turned on until you actually have a failover situation. A private carrier network is really popular for customers with a large deployment or someone with very secure data, and they don't want their traffic going out with everybody else's smartphone traffic. When the carrier provides an isolated network, and they can even create hardware isolated networks for you, and you'll MPLS into that network, or you'll VPN through a gateway on the internet. So if you're going to route between devices there, they want you to be using BGP, maybe use a GRE tunnel. They have very specific requirements inside that tunnel of what you can and can't do inside that cloud that they've created for you. So it's a great option if you need to secure your data. The only drawback is if you're a road warrior, how are you going to get in? You have to get into corporate to get into that connection. If your corporate site's down, you can't get into it. The other part is not every customer has VPN or MPLS savvy people on board or hardware, so it really needs to, it's just a pros and cons, what one works best for the customer. So really, our recommendations and best practices is choose the best plan based on your security needs, and pursue the business plans over consumer. Buy in bulk, you get a better discount the more you buy, the more units you put on that plan. And you might have a mobility group in your organization. That's a great place to start. So what are the costs of these different plans? If I'm looking at a cellular routing option for a remote location, and I go to Verizon AT&T and I say I want to set up a routing account, it's going to start at 30 gigabits and it's going to cost me $185 a month. If it's an out-of-band arrangement, then it's going to be an M2M plan, and it's $5 a month, and it's 1 meg as my entry point. And the reason for that difference is out-of-band management over cellular is really about SSH. I've got a remote site down, and I need to get in and remediate that situation. So getting in, remediating the situation, getting things back up and running, I could use as much as 100 kilobyte. I could have 10 of those instances in 1 month and still not go over that 1 meg. So when you consider you're pooling it, that's primarily the reason why the two plans cost differently. So the idea here is this is not your dad's modem. I don't even know if modem's a good word for it, but it's really not an analog VT100 modem like you used to get into AOL. It's an IP interface, and that's the thing that's most important to recognize. The plan that you get from the carrier is going to be an IP interface, and it's going to dictate your security policy. So all the standard firewalling rules and IP rules you would apply to any IP interface applies to the cellular interface. So the specific plans, it's going to be driven by your security policy. Consider tunneling. Even if you have a private network with the carrier, it's good to tunnel over that network. Consider turning off services. Do you need HTTPS on that interface? Limit the services. I mean, this is all very basic security policies, and it's all all dictated by the fact that this is an IP interface. The other thing is maybe you need to have some brute force protection on there, like fail to ban if you're facing the internet with a static IP. And also implement alerting. You want to know if that interface goes active and it's facing onto the internet because of some kind of failover situation. You should be notified that has happened. So when we talk about going into deployments, initially the biggest concern we get from customers is the signal strength in the data center or at a remote site. So it all comes down to RSSI or LTE signal strength. It's a negative number in decibels, and anything negative 40 is strong to negative 98, which is weak. If it's beyond negative 98, the device may not activate. So there's some places you could check. You can always ask people, hey, go walk in with your cell phone, or I've been in there, I know what my signal strength was. You can also go to a site, there's many like this, for instance, downdetector.com. It's a great way to track by carrier availability. The only word of warning on this is that smartphones fall into this category, but it's a good starting point. I think OpenSignal is pretty good as well, opensignal.com. It's nice there is they've got a graphic overlay so you can look at the region where your data center, your site is, and then you can drill in and you can see by 2G, 3G, 4G, you can see what, is 3G going to be a stronger signal for me? Is 4G better? What is the reliability in the area? And what is the uptime, what is the ping and download and upload speeds in that area? My experience is that 4G really has better coverage, both signal and coverage and signal strength. Cell phones, they can be conservative, so be careful if someone said, I didn't get really good signal, so cell's out for us. Be careful about that because the cell phone is conservative in its reading of that signal strength. So if you look at a site survey and you look at the best, better, and good, the cell phone's a great place to start. You can get an app on your Android. There's a GNet tracker. It's one that the Verizon SEs use, and other customers have installed it. It's a great tool. I don't recommend it, but you can put your iPhone in field test mode, and it'll show you RSSI. It'll show you the cell signal strengths. Even better is to take the actual router or the embedded cellular out-of-band management device and walk it around. They all tell you the RSSI from the user interface. And even better is, the best is a measurement tool. So you can get measurement tools that will be carrier agnostic and will tell you 3G, 4G signal strengths at your sites. Typically, when we see customers with out-of-band cellular, we see two different models, whether they're going into a data center or a remote site. At the data center, it's usually one cellular-enabled device acting as a gateway to all the other out-of-band management devices. So if there's an outage, they just need a single entry point. At a remote site, you'll see a device installed at each location. The other thing that's really important in terms of deployment is that interface handling. You need to consider how the hosts are going to route to that interface. How do they know if there's been a failover or there's a new route? Also, do you want to have that interface dormant? That saves you on costing. you're only going to use that interface when there's an outage or an emergency. It's also going to limit the amount of time the interface is available for malicious activity. You could also consider QoS. Maybe not everything needs to go over the cellular interface when there is a failover. Maybe you just need to get the most critical data across that interface. And there's also the ability to watch the interface to make sure it doesn't go above your plan levels. The one thing you don't want to be surprised by some process running out of control or the cell interface being used in a way you didn't expect and only knowing about it when the bill comes. So what are the best practices in general as a summary? Really know your carrier, know your plan options, and get your routing options in place ahead of time. Conduct a site survey, know the signal strengths in your location. Choose a plan ahead of time, because if you have to switch plans, the carrier may ding you again on a setup fee. And get to know your carrier reps. They want to talk to you. They want to sell these lines. They want to sell the cellular plans to you. And they're very good. They're very consultative. And know that if you're going to go internationally, it's going to be different. There'll be different standards internationally than in America. And don't forget about budgeting. This is one that gets passed up. And traditionally, phone lines as an out-of-band option might have been billed regionally. Now, if it's a cell plan, it might be now billed centrally. Either way, it's an item that you should include in the budget as the monthly recurring fee. They may not be high, but you should account for them. And can you roll this into your existing management fabric? Because it's a separate IP interface, it's accessible during an outage, and you can get data and you can get information and from that site even during an outage. And of course, make sure your vendor's an expert, they're focused. It's a lot of work to try to match up the right equipment for the right carrier and the right country. Your vendor should be able to help you out with that process. So coming up on my time frame here, any questions? Beer and gear?
Hi, Brandon Ross, Network Utility Force. This is actually more of a observation than a question.
Okay.
We deployed some open gear actual terminal servers with the cellular network for some troubleshooting we were doing, and this is hopefully so no one else has to spend all this time trying to figure this out. We noticed that we got what appeared to be a public IP when we first connected to the cellular network, while we were kind of expecting that it would be carrier grade NATed. So we're like, great, this is public IP, we don't have to worry about the NAT. Well, it turns out that, and I'm going to name and shame, T-Mobile uses addresses that aren't assigned to them on their cellular network that are actually NATed. So I forget whose address block it was, but it was very surprising once I looked into it that we thought we had real public IPs that they were actually NATed but not using RFC 1918 address space. So we were scratching our heads for quite some time until we figured that out.
Interesting. Interesting, thanks.
And I don't know if any of the other carriers do that too. Maybe that can turn that into the question. Have you experienced other carriers using address space that was not assigned to them?
I haven't. It doesn't mean I don't hear
Sure.
about everything.
Yeah.
What's that? Rogers. Yeah, I haven't heard of that, but that's interesting. Thanks for sharing that.
Andy Liu, J2, just wanted to know with the public addresses, if you go to different states, do they change or does it stay the same?
If the device travels?
Yes.
Yeah, typically, with Verizon and AT&T, that IP address is always assigned to that device. It's got a phone number. You can text the device and say, hey, run a script, do some things, but you can also always address it by the same address. In Canada, it's a little different. It may be a DHCP address, so as you move from system to system, it might change.
Thank you.
Joshua Goldbard, Tevnos. So my question is about cellular frequencies. So Sprint uses primarily 2.5 gigahertz for their LTE, and AT&T and Verizon are using around 900 megahertz. Inside of data centers where these the equipment that you're talking about is primarily deployed, have you seen coverage issues with higher frequency bands, or is that a non-issue?
I haven't necessarily. We typically will address situations like that by putting a cable that's longer, 20, 30, 40-foot low-loss cable, and taking the antenna over to a spot where the signal strength is greater. But bandwidth-wise, I haven't seen anything regarding that. It may be going on. I'm just not aware.
Have you had a situation where you had to implement a small cell, or is that not a thing you had to do?
Had to what? I'm sorry.
Implement a small cell?
Not yet. Not yet. Again, a customers may be doing. A lot of our customers are very self-sufficient, but I haven't heard of that. I haven't had a customer either say it wasn't strong enough and we had to switch, or we had to implement anything. Usually, they'll kind of know it's either a dead spot in the data center or not.
Got it. Thank you.
Thank you.
Wes George with Time Warner Cable. Everybody can go ahead and check their bingo cards ahead of time, but I'd like to congratulate you for spending all this time talking about IP addressing and you know, different flavors of carrier grade NAT, public versus private and static and whatever, without ever mentioning IP address exhaustion or IPv6.
Yeah, I have seen on the NANOG groups a lot of discussion around IP version 6, and we've had some discussions with customers over that, and they go to the carriers, and initially the sales teams at the carriers are kind of like, I'll have to check on that one. Their big question is, if we're IP6 here and you're not, how are we going to deal with that? Any other questions? Well, thank everybody for your attention.